Towering container and gantry cranes power global ports, synchronizing heavy lifts through advanced control systems and high-precision maritime logistics. At the port of Antwerp, a ship-to-shore gantry crane is operated to load a massive container vessel with precision and safety. Using advanced joystick controls and camera-assisted monitoring, the crane operator lifts containers from the quay and positions them accurately onto the ship's deck. The crane's long boom extends over the vessel, while automated systems help reduce sway and improve stability. This efficient operation ensures fast loading, minimizes errors, and keeps port logistics running smoothly, even with large ships. The unloading operation on board the Morten Marsk clearly demonstrates the efficiency of using a double spreader on a ship-to-shore gantry crane. This advanced lifting system allows the crane to pick up and discharge two 20-foot containers at the same time, instead of handling them individually. Thanks to this dual lift capability, the handling capacity of each crane cycle is effectively doubled, which is crucial for EEE class vessels such as the Morten Marsk, capable of carrying more than 18,270 TEU. During the discharge process, the crane operator positions the double spreader precisely over the container stack, locks onto both containers simultaneously, and lifts them in a single smooth motion. The load is then transferred swiftly from the ship to the quay, where terminal vehicles receive the containers for onward transport. This method significantly reduces the number of crane movements required to clear each bay. In major ports like Rotterdam, modern STS cranes aim for productivity levels of around 37 moves per hour. By using a double spreader, terminals can maintain these high-performance benchmarks, improving turnaround time, reducing vessel berthing duration, and maximizing port efficiency for ultra-large container ships. Loading containers onto a ship's deck using a gantry crane becomes significantly more challenging when strong winds are present. In the video, the ship-to-shore gantry crane carefully lifts containers from the quay and transfers them toward the vessel, while wind forces cause the suspended loads to sway unpredictably. To maintain control, the crane operator relies on precise joystick movements and constant coordination with ground staff and signalmen. As the container is hoisted, tag lines are often used to reduce rotation and lateral movement. The crane spreader locks securely onto the container's corner castings, ensuring stability during lifting. Wind speed and direction are continuously monitored, as excessive gusts can compromise safety and accuracy. When conditions are borderline, crane movements are slowed to prevent sudden impacts with the ship's structure or other containers. Once the container is positioned above the deck, the operator carefully lowers it into its designated slot. Deck workers guide the final alignment, ensuring the container lands smoothly on the twist locks without collision. After placement, the spreader is released, and the crane prepares for the next cycle. Despite adverse weather, disciplined procedures, skilled operators, and advanced crane control systems allow container loading to continue safely and efficiently, even under demanding windy conditions at the port. The Hyster Empty Container Handler is a purpose-built material handling solution engineered to meet the demanding needs of modern ports, container yards, and intermodal terminals. Designed specifically for handling empty shipping containers, this machine plays a vital role in optimizing yard operations where speed, stacking density, and reliability are critical to daily productivity. At the core of the Hyster Empty Container Handler's design is its ability to efficiently stack and transport empty containers in high-density layouts. Thanks to its robust mass structure and specialized container spreaders, the machine can safely handle containers at impressive stacking heights while maintaining excellent stability and control. One of its standout capabilities is double handling, which allows the operator to lift and move two empty containers simultaneously. This feature significantly increases throughput per cycle, making it an ideal solution for terminals experiencing growing container volumes and tighter turnaround times. Performance optimization is another key strength of the Hyster Empty Container Handler. The machine is equipped with advanced technologies such as on-demand hydraulics and on-demand cooling, which ensure that energy is used only when required. These systems help reduce fuel consumption, lower operating costs, and minimize noise levels, an important advantage in busy port environments that operate around the clock. In addition, selectable performance modes allow operators to adjust machine behavior to match specific tasks, balancing power and efficiency depending on operational needs. Operator comfort and visibility are central to the machine's design philosophy. The latest Hyster cabins feature a high visibility layout with large windows and armored glass, providing a clear view of the load, mast, and surrounding work area. This enhanced visibility improves safety and precision during stacking operations. Inside the cab, operators benefit from digital performance displays that deliver real-time machine data, enabling better control and awareness. Ergonomics are further improved with a lateral sliding seat, allowing operators to maintain a comfortable posture during repetitive container handling, thereby reducing fatigue over long shifts. Durability and ease of maintenance are also defining characteristics of the Hyster Empty Container Handler. Built to withstand harsh terminal conditions, the machine features heavy-duty components and a rugged frame. Extended service intervals help maximize uptime, with standard maintenance checks required only every 500 operating hours. Even more impressive, the hydraulic oil can last up to 10,000 hours when monitored through oil sampling, significantly reducing maintenance frequency and operating costs. To further enhance fleet efficiency, Hyster equips its empty container handlers with Hyster Tracker as standard. This wireless asset management system provides real-time data on truck utilization, operating hours, and operator performance. By giving fleet managers clear insights into how machines are used, Hyster Tracker supports smarter decision-making, improved productivity, and proactive maintenance planning. In summary, the Hyster Empty Container Handler combines powerful performance, intelligent efficiency, operator-focused design, and advanced fleet management technology. It is a reliable and future-ready solution for terminals seeking to handle empty containers faster, safer, and more efficiently in an increasingly demanding global logistics environment. The Konecranes SMV 4531 TC5 is a heavy-duty reach stacker designed to meet the demanding requirements of modern ports and logistics terminals. Built by Konecranes, a globally recognized leader in lifting equipment formerly known as SMV, this machine combines high lifting capacity, extended reach, and precise control to ensure efficient container handling operations. Specifically engineered for container transport and stacking, the SMV 4531 TC5 is capable of handling standard 20-foot and 40-foot containers with ease. With a maximum lifting capacity of approximately 45 tons, it can safely manage heavy loads while maintaining excellent stability, even in congested yard conditions. Its powerful telescopic boom allows containers to be lifted to heights of up to 15.3 meters, enabling multi-level stacking and optimal use of yard space. In operation, the reach stacker demonstrates smooth and accurate movements, allowing operators to position containers quickly and safely. Advanced hydraulic systems ensure responsive lifting and lowering, while the robust spreader provides secure engagement with containers during lifting, transporting, and stacking cycles. The operator's cab is ergonomically designed, offering excellent visibility and intuitive controls that reduce fatigue and improve productivity during long working shifts. The Konecranes SMV 4531 TC5 is widely used in seaports, inland container depots, and large logistics centers, where flexibility and speed are critical. Unlike fixed gantry cranes, this reach stacker can move freely across the yard, making it ideal for dynamic container handling environments. Overall, the Konecranes SMV 4531 TC5 represents a powerful and reliable solution for high-capacity container handling. Its combination of strength, reach, and operational efficiency makes it an essential asset for modern container terminals and logistics operations worldwide. This video provides a basic introduction to a shipboard cargo crane commonly installed on container ships, general cargo vessels, and bulk carriers. The crane is designed to handle various types of cargo, including containers, bulk grain, and heavy units, offering flexibility for different port operations. The crane operates through three main motions. The first operation is slewing, where the entire crane structure rotates through 360 degrees, allowing cargo to be moved across the deck or over the ship's side. The second operation is luffing, which involves the movement of the crane jib. The jib, sometimes referred to as the jib arm, moves upward and downward to adjust the working radius, known as luffing up and luffing down. The third operation is hoisting, where the hook is raised and lowered using a hoisting wire connected to a hoisting winch, enabling safe lifting and lowering of cargo. This electro-hydraulic cargo crane has a lifting capacity of approximately 40 tons and is manufactured by Sleipnir, a well-known supplier of marine cranes. On the machinery deck, key components include the slewing gear, slip rings with carbon brushes for power transmission, and electrical cabinets housing essential control and protection systems. Multiple emergency stop switches are installed throughout the crane for operational safety. The operator's cabin is equipped with joysticks for precise control, window wipers, lighting switches, and clear operational indicators. An emergency rescue device allows the operator to evacuate safely if required. The crane system also includes hydraulic oil tanks, cooling fans, electric motors, hoisting winches, limit switches, and warning lights. Together, these components ensure reliable, efficient, and safe cargo handling operations at sea and in port. Stennis Lifting Equipment provides a comprehensive range of advanced solutions designed to meet diverse container handling demands in modern ports and terminals. Its fixed spreaders, including the reliable auto-twist model, offer simple operation with automatic locking for improved safety and efficiency. For mobile harbor cranes, Stennis supplies precision-engineered spreaders with double-pin connections, available in single and twin-lift configurations. Ship-to-shore crane spreaders are built for high performance, handling containers from 20 to 45 feet and supporting optional cameras and shock absorbers. Yard crane spreaders feature telescopic monobeam designs for visibility and easy maintenance. Specialized solutions include overheight, piggyback spreaders, and the innovative split-head block system. At the Evergreen Terminal in the Port of Los Angeles, hammerhead cranes play a critical role in loading and unloading massive container ships that arrive from around the world. On any given operation, up to 5 hammerhead cranes may work simultaneously on a single vessel. These cranes are strategically positioned along the ship's length, with the crane at the stern referred to as the after crane, the one at the bow known as the forward crane, and several midship cranes handling the bulk of the work. In this operation, attention is focused on the mid-forward crane, which is actively lowering containers into the ship's hold below deck. Modern container ships are designed with both below-deck and above-deck storage areas. During this phase of the operation, containers are being carefully placed below deck into guided vertical cells. The crane operator, a skilled longshoreman working for Evergreen, controls the crane from a high cabin suspended above the dock. From this elevated position, he operates a large lifting frame, known as a spreader beam, which locks securely onto the container's corner castings. Once a container is released into the ship's hold, the operator guides the beam back toward the land side. There, a container awaits on a UTR truck, mounted either on a chassis or a bomb cart. If the container is on a chassis, ground personnel disconnect it before the crane lifts. The operator then lowers the beam, locks onto the container, hoists it smoothly, and swings it out over the ship. Precision is essential, as the container must clear existing stacks before being carefully lowered into its assigned cell. Containers come in standardized sizes: 20-foot, 40-foot, and 45-foot units. In this operation, most containers are 40 feet long, while the slightly larger 45-foot containers are visible stacked higher on deck. These uniform dimensions are a cornerstone of intermodal transportation, allowing containers to move seamlessly between ships, trucks, and trains anywhere in the world, much like giant building blocks. The Port of Los Angeles operates around the clock, supported by longshore labor crews working 3 shifts: a day shift, a night shift, and a connecting hoot shift. This 24/7 operation reflects the port's importance as the largest container port in the United States. When combined with the neighboring port of Long Beach, the complex ranks among the top container ports globally and supports approximately 86,000 regional jobs. From the crane operator's perspective, every move requires constant judgment. The beam must be lifted high enough to clear container stacks, aligned precisely with offset cell guides, and lowered slowly to avoid hard impacts. Landing lights signal a safe set-down before the container is unlocked. Over the course of a shift, the operator may complete hundreds of container moves, steadily working from offshore to inshore cells until the below-deck area is fully loaded. Once operations are complete, the ship prepares to sail, often heading north to ports like Oakland or Vancouver before crossing the Pacific to Asia. Behind this smooth departure lies the quiet skill of hammerhead crane operators, whose steady hands and experience keep global trade moving efficiently through the Port of Los Angeles. The creation of the claw begins with a carefully planned fabrication stage, where the concept is transformed into physical components. High-strength steel plates are precisely cut using CNC plasma and laser machines to achieve accurate shapes and tight tolerances. These parts include the main gripping arms, structural frames, pivot points, and reinforced joints. Skilled welders then assemble the components, applying heavy-duty welds to ensure maximum strength and durability. Throughout fabrication, dimensional checks are carried out to confirm alignment and structural integrity. Next comes the construction phase, where fabricated parts are integrated into a complete working unit. Hydraulic cylinders, hoses, and control systems are installed to provide powerful and responsive movement. Pins, bushings, and bearings are fitted to allow smooth articulation of the claw arms. Protective coatings and industrial-grade paint are applied to prevent corrosion and extend service life, especially in harsh working environments. Once construction is complete, the claw undergoes rigorous testing. Engineers test hydraulic pressure, gripping force, and operational stability under controlled conditions. Each movement is carefully monitored to detect leaks, misalignment, or abnormal stress. Adjustments are made to ensure smooth operation and reliable performance. The process concludes with the first lift, a critical milestone that demonstrates the success of the entire build. As the claw lifts its first heavy load, it confirms the strength of the structure, the precision of the hydraulics, and the effectiveness of the design, marking the transition from concept to fully operational equipment. In 2014, Versabar's VB10000 successfully used its innovative claw system to lift 4 sunken topsides from the seafloor. The claw consists of 2 identical grappling units, each 122 feet tall, 112 feet wide, and weighing 1,000 tons. Controlled by the VB10000, each claw operates independently or together for heavier loads. To minimize seabed preparation, custom-engineered cradles were placed next to the wrecks. The claw carefully lifted each damaged topside onto a cradle, then raised the entire assembly to the surface, avoiding further damage. This method showcased the claw's flexibility, allowing efficient and stress-free salvage in challenging offshore conditions. The Sleipnir, the world's largest heavy-lift crane vessel, arrives at the Able Yard in Haugesund shortly before Easter, marking a significant milestone in offshore lifting operations. Measuring an impressive 220 meters in length and 100 meters in width, Sleipnir's sheer scale immediately dominates the Karmsundet Strait. On board this extraordinary vessel are two colossal cranes, each capable of lifting up to 10,000 tons, making Sleipnir unmatched in heavy offshore construction. The operation focuses on lifting a 600-ton riser module from the quay and loading it onto the vessel. Positioned approximately 100 meters from the quay, Sleipnir prepares for a highly demanding lift using a 135-meter crane boom. Such a long outreach and precise control make this task particularly challenging, requiring a vessel of Sleipnir's size, stability, and lifting power. As the crew carefully hooks up the module, the lift begins smoothly, demonstrating the vessel's advanced engineering and the crew's expertise. The module is a critical building block for the Snor expansion project, as it will later receive oil from new offshore wells. Watching this massive structure rise from the quay highlights the extraordinary capability of modern heavy lift vessels. Despite the restrictions imposed during the COVID-19 period, the operation is executed safely through careful planning and strict procedures. Abel and Hirama coordinated closely, ensuring that teams were never in the same area simultaneously. The lift is successfully completed, and the module is later installed on the platform on Good Friday, making the operation a memorable and important achievement for all parties involved. A critical lifting operation on an offshore oil platform, where a large steel riser pipe is carefully lowered onto the deck using a gantry crane. This operation is an essential part of offshore oil and gas construction, requiring precise coordination, strict safety control, and experienced crane handling. At the start of the process, the riser section is secured to the gantry crane's lifting hooks using certified slings and shackles. Before the lift begins, the crane operator, rigging crew, and deck supervisors conduct final safety checks, confirming load weight, balance, weather conditions, and communication signals. Once clearance is given, the gantry crane slowly takes up the load, lifting the riser vertically and stabilizing it above the deck area. As the lowering operation begins, the crane carefully controls the hoisting speed to minimize swinging caused by wind or vessel movement. Tag lines attached to the riser are handled by deck crew members, allowing them to guide and align the pipe accurately during descent. The gantry crane's rigid structure and synchronized hoist system provide high stability, which is essential when handling long and heavy tubular components offshore. Throughout the descent, constant communication is maintained between the crane operator and deck personnel. The operator makes fine adjustments in response to hand signals or radio commands, ensuring the riser remains aligned with its designated support points. The movement is slow and deliberate, emphasizing safety and precision rather than speed. As the riser approaches the deck, the crane reduces its lowering speed even further. The crew guides the pipe into its final position, ensuring correct orientation and preventing contact with surrounding structures or equipment. Once the riser is safely seated on its supports, the load is gradually released and the lifting gear is disconnected. This operation demonstrates the efficiency and reliability of gantry cranes in offshore environments. By combining powerful lifting capacity with precise control, the crane enables the safe handling of large riser sections, supporting the smooth installation and assembly processes essential to offshore oil platform operations. The TIWB drilling rig operating in western Kansas represents a compact yet highly efficient onshore oil and gas drilling system. Designed for reliability in flat prairie conditions, this rig supports continuous drilling operations while maintaining a strong focus on safety and control. In the video, roughnecks are seen coordinating closely on the rig floor, handling drill pipes, monitoring equipment, and ensuring smooth rotation of the drill string. A key feature of the TIWB rig is its drip system on the brake, which helps control friction and heat during hoisting and lowering operations. This small but important system improves braking performance, reduces wear, and enhances operational safety, especially during repetitive lifting cycles. The rig's layout allows crews to work efficiently in a confined space, minimizing unnecessary movement while maximizing productivity. Overall, the TIWB drilling rig reflects the practical engineering approach used in western Kansas, where dependable equipment and skilled roughnecks work together to deliver safe, steady, and cost-effective drilling operations. With a total length of 196 kilometers, the A10 motorway encircling Berlin is the longest motorway ring in Europe. As the main traffic artery around the German capital, it carries an enormous volume of vehicles every day. Consequently, the pavement is subjected to extremely high mechanical and thermal stresses, making regular rehabilitation essential to maintain safety, ride quality, and long-term durability. In November 2014, the construction company Eurovia won the contract to rehabilitate a 3-lane section of the A10 motorway. The project involved replacing both the binder and surface courses over a 4.2-kilometer stretch leading up to the Schonefelder Kreuz junction. What made this project particularly demanding was a groundbreaking requirement. For the first time, the pavement had to be laid without any transverse joints across the full width of 15.5 meters. To achieve this, a high compaction screed in the TP1 version was specified, marking a true world premiere in large-scale asphalt paving. Only one paver in the world was capable of meeting this extraordinary challenge: the Vogel Super 3 000-2. Supplied for the A10 project by Wirtgen Group subsidiary Vogel, this gigantic paver is designed specifically for ultra-wide paving applications. It offers a maximum paving width of up to 16 meters and an impressive laydown rate of up to 600 tons per hour, making it ideally suited for large motorway projects where productivity and quality must go hand in hand. However, achieving top-quality pavements over such exceptional widths requires more than just a powerful paver. It demands perfect coordination between machine technology and logistics. Two of the most critical challenges are maintaining a virtually constant asphalt mix temperature and ensuring an uninterrupted paving process. To meet these requirements, Eurovia used the Vogel MT3000-2I offset power feeder to supply material continuously to the paver. The MT3000-2I offset is equipped with a modern laser system mounted beneath its pivoting conveyor. This system automatically controls the distance to the paver, allowing the operator to focus entirely on smooth and efficient material transfer. Thanks to the wide contact surfaces of their crawler tracks, both the power feeder and the Super 3000-2 run extremely smoothly, which further simplifies the transfer of material and minimizes the risk of segregation. Powerful separate drives in the sprockets of the crawler tracks ensure constant tracking and stable movement, even under high loads. As is typical when paving at large widths, the paver operator is also assisted by an automated steering control system using sonic sensors. The Vogel system traces a tensioned wire installed along the safety barrier, keeping the paver precisely on course throughout the operation. For grade and slope control, the Berlin team relied on Vogele Niveltronic Plus technology. Combined with a large multiplex ski as the sensor system, this setup ensures exceptional accuracy in both longitudinal evenness and cross-slope. The seamless interaction between machine technology, sensor systems, and control electronics results in a consistently high paving quality across the entire width of the carriageway. The complete paving system, consisting of the MT3000-2I offset and the Super 3000-2, can temporarily store up to 45 tons of asphalt mix. This large buffer enables non-stop paving, even when working at extreme widths, such as those required on the Berlin Ring Road. In addition, the Vogeli material handling concept ensures that the mix remains both thermally and mechanically homogeneous. Conically shaped augers in the power feeder continuously mix slightly cooler material from the outer areas with warmer material from the center of the hopper. This process equalizes the temperature across the entire mix. Heated conveyors prevent the asphalt from cooling and sticking, while the trough-shaped belt design minimizes mechanical segregation. As a result, the material arrives at the paver's large receiving hopper as a compact, uniformly mixed mass. This hopper is specially designed to prevent material from sticking to corners or edges. From there, conveyors and large augers with optimized blade geometry transport the asphalt to the screed in optimal condition. To further stabilize mixed temperature, asphalt delivery trucks are fitted with thermally insulated dump boxes, preventing heat loss at the corners and along the sides. For optimal pre-compaction, the project relied on the SB300 TP1 fixed-width screed. This exceptionally robust screed is designed for rapid setup and features the TP1 high compaction system, which includes a tamper and a pressure bar. Both the fixed and hydraulic extensions are electrically heated, ensuring consistent compaction and surface quality across the entire paving width. Operating such a large and powerful machine requires a reliable and user-friendly control system. This is where Vogel Ergo Plus excels. Its logical layout allows operators to intuitively understand and control all key functions. Automated features, such as steering with a pre-selected track position, reduce operator workload and ensure precise tracking through curves without manual intervention. Ergonomics and safety are further enhanced by features such as ergonomically shaped joysticks, backlit operator consoles, and Vogel light balloons, which provide excellent visibility even during night operations. Together, These innovations enabled the successful completion of one of Europe's most demanding asphalt paving projects, setting new standards for jointless, ultra-wide motorway construction. The new Genoa Bridge was delivered to the people of Genoa in record time. After completing the piers and steel structure in just 10 months, construction moved rapidly toward completion. The 1,067-meter-long bridge spans the valley and is formed by 19 steel deck segments welded into a single structure, supported by 18 piers up to 40 meters high. Hundreds of workers operated day and night, completing elevated works, installations, safety systems, and final finishing stages.